Pues ya sin más dilación, creo que vamos a dar paso a Nassim Haramein.
Buenos días. It's great to be in Spain. Gracias. Gracias. It's great to be in Spain. I wish I knew a little more Spanish. Thank you so much for coming. Thank you for being here. I'm really excited to present this work to you. There'll be a lot of things that were there that you might have seen before, but we'll get in more details about it, and then there'll be new stuff. I'm going to present some new stuff. Can you all hear me in the translation? Good. I really love this country. I went and traveled a little bit through it. It's wonderful. I went to Basque and surfed a little bit. So you guys have great surfing. I'd love to go climbing one day here. I'm excited to bring some of this work to you because, we're at this moment in our evolution where we have to make some changes. We have to make some changes in our society. We have to make some changes in our world so that our society can thrive, so that the generations to come have an earth to live on. And in order to be able to make these changes, we have to do some radical changes as well in our philosophy, in our understanding of the universe, in our understanding of our relationship to the universe. The current thoughts are very much based on the concept that things are separated, that things are individualized, that a point over here and a point over there don't necessarily relate to each other. So I can do this over here and not worry about this over there because it's not going to affect it. And as we grow, as we expand our society, as we grow on this earth, we're starting to realize, everything seems to be interconnected. If I change this too much, then this will start to go out of balance, and then this wobble will produce this other wobble and all this. And so now we have to understand how things relate to each other, how they connect with each other, so that we can regain balance. Yes? And so part of what I'm going to present today to you is the result of a small paper that's making a lot of noise. I have to dodge a lot of tomatoes and rotten eggs, It's a small paper that I published last year it's in the process of being published. It is going to be published in the next few months in one of the largest scientific physics journal. And it was presented at a conference in Liège, University of Liège, in the Department of Mathematics, and it's called the Schwarzschild Proton. And I was really excited to be able to present that paper because, usually when I want to present papers to the scientific community, I apply to put it in, the conferences, and then, I hope that I will be able to present it. But in this case, for the first time, the conference asked me to present a paper. That is, it was an invited paper. And so, because it was an invited paper, I thought, I can say what I want. So I went for it. And I made this very simple paper that any student that has done a little bit of mechanics, a little bit of math can follow. And so today, we're going to actually do a little bit of those math. Don't panic. It's not going to hurt. It might hurt a little bit, but then it's okay. And I'm going to run you through the equation that describe this new view of the quantum world, this new view of the material world we live in. And, you know, when I presented it at this conference, although it was an invited paper, I thought, oh, you know, it's very radical. Maybe I get in trouble anyway. And so when I arrived at the conference, I was a little nervous. And, you know, in the middle of the conference, the director of the conference came to me and said, I would like to talk to you. And I thought, oh, there we go. He might ask me to leave, you know, not present my paper or something. And he bring me and he says, you know, we looked on the schedule and you're leaving before the award ceremony. And, you know, I had done that on purpose because usually I don't get awards. Usually I just get a kick in the butt, you know. So he said, oh, well, you know, we would like you to stay for the award ceremony. I'm like, why? He said, well, I'm not supposed to tell you, but your paper in the peer review passed for the best paper award. And I was in shock. Am I on the same planet? Did I hear this right? And I was like, oh yes, I'll change my plane ticket. And so, you know, I think it won this award, although it's upsetting many other physicists, because it's so simple and it's elegant. It describes the atom in a very radical but elegant way. And we're going to look at it today. So let's begin. Let's see. Okay. Barcelona. Wonderful. So, you know, I'm going to run you through. How many here have seen my DVD? Ah, I see. So I'm going to run you through the basics a little bit. You know, even if you've heard it before, stick with the process because it's always good to hear it again, and I'm going to give you a little more details. This started when I was fairly young. I was about 9 years old. It started earlier than that. I had all sorts of esoteric experiences when I was very young, you know, between the age of 5 and 7. I had many esoteric experiences, and I was an unusual kid. I didn't fit in very well in the schooling system. I was not doing so good because I was living in I had this whole other world that I was interacting with. And so when I was sitting at school, you know, for hours and hours, I was spending a lot of time in this other world, and I wasn't paying attention much. And that didn't go so well, you know, in school. And but you know, when the teacher went to the blackboard when I was 9 years old, and he said, today we're going to learn about dimensions, then that caught my attention. Because I had all these other dimensions going on, so I thought, oh my God, adults know about these? And I thought, oh, he's going to talk about all these other worlds and all this. I'm like, I don't know any adults that know about this. And I thought, wow. And then I was so disappointed. Because it wasn't that at all. What he did is he made a little black dot, a little white dot on the blackboard. And he said, this is the first dimension. Dimension 0. And it doesn't exist. And from that moment on, I knew I was going to fail that class. I knew I wasn't going to do so good. Why? Because I was sitting in the back of the class, and all the way from the back of the class, I could see the dot. So if it didn't exist, how could I see it? How could I experience it? I'm there, I see it, it must exist. And then he did something remarkable. He took a bunch of dots and put them in a line. And said, that's dimension 1. And it still doesn't enclose volume, so it still doesn't exist. And then he took 4 of those lines, put them together into a plane, and said, the plane is 2-dimensional. It is the dimension that your comic strip books live in, and it still doesn't exist. Because it doesn't enclose volume. And I could see all the other kids in the class were very crushed that their superhero didn't exist. And then he took 6 of these non-existing planes, put them together into a cube, and said the cube encloses volume. The cube is the 3rd dimension, and that one exists. And then I was really confused. Because if you have a dot that doesn't exist, that makes a line that doesn't exist, that makes a non-existing plane. I don't care if you slap 300 million non-existing planes together, you still don't get existence. In this case, all you have is non-existence to the 4th. Non-existence 4 times over. So, I was coming back from a physics conference once with a very, very, a famous mathematician. And he was having a really hard time because he was sitting beside me in the plane coming from Georgia all the way back to California. And so that's a long flight. And he had me on one side and, 37,000 feet on the other. And so he was stuck. And I asked him, we were discussing space and time, and he was saying that, space and time is flat on long cosmological distances. And I was saying, you mean like a 2-dimensional plane flat? And he says, yeah, like flat. And I'm like, okay, well, what I would like to know is how thin is flat? How thin is the 2-dimensional plane? And he looked at me and he's like, oh, scruffed. And he said, well, it's infinitely thin. Okay. Now we're getting somewhere. And so, when I was coming back from school after that lesson, I, was in the bus, and I had this long bus ride, and it was an hour and a half because I kept on getting kicked out of the schools closer to my home. And, I was furthering my education that way. And that day I had all this time to think, so I'm thinking about this, and I'm thinking, wait, how do I solve this? I need to know what a dimension we live in. What is this thing we're living in? I couldn't go one more day without knowing. I had to figure it out. Now, I didn't know that many philosophers and mathematicians and many people had worked on this riddle, had worked on this problem. I was just 9 years old. I thought, hey, I want to solve this before I get out of the bus. I think the universe had pity on me. Otherwise, I would still be in the bus turning in circles, you know. And it turned out that, you know, Buckminster Fuller, you know, a famous geometrist and engineer, had worked on this problem. You know, many philosophers in ancient time had worked on it. But for me, sitting in that bus, there must have been a fundamental solution to it. And I thought about it, and I closed my eyes when I was thinking, and in my mind's eye, I rose above the bus. And as I rose above the bus, I saw the bus becoming a dot. And as I rose further, I saw the city I was in becoming a dot. And as I rose further, I saw the earth becoming a dot. And I rose further and I saw the solar system becoming a dot. And I rose further and I saw the galaxy becoming a dot. And I thought, oh, it's dots all the way up. And then I flew back into the galaxy, I flew back into the solar system, I flew back in to the city I was in the bus I was in, and I opened my eyes and I looked at my hand and I thought, I wonder what that's made of. And I closed my eyes and I flew into my hand, and in my mind's eye I saw that it was made out of millions of dots we call cells. And then I flew onto the surface of one of those cells and I looked really closely, and all of a sudden it opened up and there was billions of little stars, little atoms. Right? And then I flew onto one of these atoms, and sure enough, what was in the middle of it? A little dot. And then I flew into that one, there was another dot. And I thought, oh my God, it's dots all the way down. And that's when I realized that the only way to solve this riddle is to come to conclude that the only thing that exists is the dot. The exact contrary of the current axioms for our dimensions. Why is this important? Because, you know, all of the math, all the physics we're writing, most of the physics we're writing to describe our world are based on these axioms of dimensions. And if they were not quite complete, if they were a little bit wrong or a little bit skewed, then the answer we would get would be a little bit skewed. And then if we took those physics and we extrapolated philosophy from it, then those philosophy would be a little bit skewed. So it was really important to me. And I got really excited. I opened my eyes. I was in the bus and I looked at people and I could see they were made out of dots that were made out of smaller dots and smaller, billions of them. And I was like, wow. And everybody seemed to glow a little bit. I was having this moment, you know. I'm sure you've had moments like that. And you know how it is when you get those moments, the first thing you want to do is tell someone. And you know usually how that goes, right? You get that look like, huh? Did you take your medication this morning? And so when the bus got to my place, I ran out and I went home and I waited for my mom to come back from work. And when my mom arrived, I'm like, Mom, I figured out something at school today. And she was like, oh. And it's like, that was the first time she ever saw me excited about school. She's like, oh my God. I'm like, Mom, I learned about dimensions today and I think they're wrong. Oh, the look of despair in my Italian mother, you know. There's a force there that has not been calculated in physics yet. She looked at me and she goes, oh no. And I'm like, Mom, you're made out of dots that are made out of smaller dots that are made out of smaller dots to infinity. You got infinity in every dot that you're made of, Mom. And she was like, really? Yeah, Mom. She goes like, I just worked for 8 hours right now and I really don't feel infinite. And if you answer that at school, you're probably going to fail. So, she had made a very important point. If you have finite system and you have infinite division, how the two relate? If you have infinity and finite system, how do the two relate? If everything is infinite, how come everything is not falling into itself? How can you have distinction? How can you have boundaries, condition? Right? So I had to think about that. So I thought, I better stop talking about this because, I got to find a solution. And so I thought about it for a very long time. By the age of 11, I learned to meditate. There was a young master of meditation from India that taught me how to meditate. It was important for me because I was quite discouraged by that time with the human species. I was ready to exit. And I learned that there was a whole internal relationship, that maybe there was a whole internal world to discover, that my senses might not just be outside myself, but I might have senses that are going inside myself. And I thought, maybe there's a solution there. I didn't know at the time, but this difficulty between infinite and finite system is a fundamental chasm in our society. It has separated our physics, for instance. We have physics for the big stuff. Einstein field equation. It deals with galaxies, universes, stars, planets. And it predicts that space-time curve in a continuum fashion towards singularity, towards infinity. And then when we look at the atom, we have another set of physics. And those physics are quantum theory that predicts quantum numbers, finite linear structures. And the two don't agree. But this chasm between infinity and finite system is even bigger, much bigger. You can see it, for instance, between the spiritual people and the scientific people. Spiritual people have a tendency to think in infinite amount of possibilities. Infinite continuum. Infinity is everywhere. And scientific people tend to think in finite, closed system, analytical solutions. Right? And so, commonly, the two don't agree. The chasm is even deeper. You can find it between male and female, men and women. Women have a tendency to think in infinite amount of possibility, continuum. Oh yes, honey, I can handle this 25 tasks, no problem. I'll just, multitask the whole thing. And males typically are trying to analyze a closed system and then, fundamental, pieces at the time. And actually, honey, I'm busy with one thing. Don't disturb me. Right? And so one has infinity continuums in mind, the other one has quantum functions in mind, and it can happen that the two don't agree. Thus the rate of divorce, And so, how do we reconcile the two? How do we put the two together? So, I'm going to show you in very simple geometry that the two agree with each other. That actually the two are complementary, that you can't have infinities without finite boundaries, and you can't have finite boundaries without infinities. We'll start with a circle, and we'll say that this circle defines a space, a finite space. And remember here, that circle could be a sphere, right? It could be a sphere that defines a space. And inside it, I'm going to put an equilateral triangle. Now, that triangle in a sphere could be a tetrahedron, right? So, a tetrahedron is the fundamental geometry, Platonic geometry, three faces with a triangle base. And we could say that the universe has spin, right? Everything we see seems to have spin and is polarized. So if it's polarized, then there should be a reverse triangle. Now, interestingly, for the people that are interested in that section of the lecture, right away we have a symbol that's found in many, many different ancient cultures all around the world. Now, notice when I polarized the triangle, what happened? Right away, I defined a new set of boundary that's exactly the same geometry I started with, but at the next scale, at the next iteration. I can polarize that, and now I've done it again in the next scale over. It's very important that you understand that each of these boundaries define a very specific coordinates in space-time. That is, that the center of each of these boundaries is actually on its own very specific coordinates. Although it's part of the whole system, each one is a complete individual because it observes from its own very specific perspective in which no other boundary can observe from. You all following this? So, I polarize that. And now I get even smaller boundaries. And I could continue to do this and get smaller and smaller and smaller and smaller and smaller and smaller boundaries. In fact, if I give this geometry, if I give this program to my computer and I ask it to keep doing boundaries and then zoom in and then keep doing boundaries and zoom in and do boundaries and zoom in, it would continue to make boundaries to infinity and beyond. However, I would never, ever, 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 ever exceed that first boundary that I started with. I would never come out of it. I would continue to divide within the context of what appears to be a finite space. Now, remember, each boundary defines a very specific set of coordinates from which it observes the universe from, right? So each boundary represents a very specific set of information. Each boundary thus represents a very specific set of energy. And so, If I can divide to infinity within the context of a finite space, that means I could have infinite amount of information inside the boundary of a finite space. Infinite amount of information. Why is this important? It's important in many different ways. It's important in philosophy, it's important in spirituality, it's important in physics. Why is it important in physics? Because if the mainstream scientific community understood this, we would stop building accelerators. Right? Not so long ago, the scientific community got their first microscope, and they saw the cells at the biological level, and they said, oh my God, cells are so small. They must be the smallest thing the universe does. And then we had atoms. We realized that cells are made out of billions of atoms, and we went, oh my God, atoms are so teeny. They must be the smallest thing the universe does. And then we discovered that in the middle of atoms, there's a teeny weeny little beady little dot. Protons and neutrons, and we said, oh my God, those are so teeny. They must be the smallest thing the universe does. And then we start to scatter, with building accelerators, colliding atoms and getting smaller chunks and smaller chunks, a zoo of smaller chunks, and every time we thought, oh, this has got to be the God particle, it must be the smallest thing. And every time we had to build larger and larger and larger and larger accelerators so that we can collide atoms at faster and faster and faster rate. Now we've built the largest accelerator ever built, and we've reached practical limits. The Hadron Collider. 17-mile long, Every time they turn it on, things go wrong, because it's one time the coils ripped off the anchor, and went flying 17 miles and embedded themselves in the detectors, and then the whole thing flooded with liquid helium, and they had to evacuate all of CERN, and, the thing is huge. I'm amazed when they turned this thing on. I thought that all of Europe was going to dim, Honey, shut down the washing machine. They turned it on again. So, we've reached practical limit. But if this was understood, then we would understand that we can keep colliding atoms into smaller and smaller pieces. We're not going to get to the end of it. That there's infinite amount of division possible. So that what is important may not be if there's a fundamental particle, but if there is a fundamental pattern of division. Maybe there's some fundamental geometry that divides the space. Maybe that is what we should be looking for. Because if we understood the pattern of division, now we would understand the fundamental key of creation, the fundamental key on how the universe creates the complexity of our world. And that could be useful. So, I was thinking about this, but you gotta think about it as well in terms of philosophy. I mean, first of all, if there's infinite amount of division in each boundary, that means that each atom that you're made of could have infinite amount of information in it. So that means that within yourself is infinity. That has large consequences in your understanding of yourself. Did you think of yourself as an infinite being? I mean, not in a spiritual way, in your material world. And that kind of leads to this understanding that maybe, just maybe, you have this infinite potential. But when you think about it, if you can be divided to infinity, what are you dividing? Maybe you're dividing the space. So let's do a little mental experiment. I'm going to ask you a question. If you wanted to find something that connects all things, what would that be? If I give you the whole universe, and I say to you, find me something that connects all things. You know, because a lot of spiritual people nowadays, they say, oh, don't worry, we're all one. Oh, it doesn't matter, we're all one, right? Well, how? How are we all one? It's not apparent. You seem to be over there and I seem to be over here. How are we all one? So if we wanted to say, okay, if we're all one, there must be something that connects everything, what would it be? If we had to think about it, what would we find? The only answer you could come up with, the only thing you could point to me and say, that is what connects all things, is space. Why? Because space is everywhere. It's between galaxies, between quasars, between stars, between, planets. It's between atoms, it's between cells, it's between atoms. In fact, if you take the densest atom, the densest molecule, like diamond, and you grew one of the atoms in the diamond molecule so that it becomes an orange size, then the other orange, the other atom would be 2 football fields away. That is how much space there is between things. Atoms don't touch. Do you realize you have never touched anything? Nothing. Nothing touches. If things started to touch, if the nuclei of atoms started to touch, you would have fusion. It would be a problem. In fact, when you so-called touch something, there's a lot of space. All there is interaction between electromagnetic fields bouncing off each other. Nothing is actually touching anywhere, at any point, at any time. And then when you look inside the atom, what you find? The atom is 99.9999999% space. All of the material world you see around you, everything you're looking at, your body, everything is 99.9999999% space. It's mostly space. With a little teeny little wiggle. We call magnetic component, magnetic moment, a little wiggle. 0.0000001%. This is what we pay a lot of attention to, the wiggle. When I realized that early, I thought, maybe we're paying too much attention to the 0.00001%. Maybe we should pay attention to the 99.9999999%. Maybe the material world is just a function of the space itself. Maybe space just divides itself, and where it divides, it wiggles a little bit, and we see it as reality. Maybe it's not matter that defines space, but maybe it's space that defines matter. So, can you experience right now your spatial self? All that space that you are you aware of it? Or are you only aware of the 0.0001%? So, it started to make sense to me that maybe space is the function, is the source of all the material world. It's everywhere. It would be able to connect all things. It would be connecting everything. Everything radiates into the space. So the space would know what everything is doing. It could be the organizing agent. Because in current physics, there is no space anywhere in our understanding for self-organizing systems. Meaning, general relativity or special relativity or quantum theory does not predict biology. It doesn't predict us with all of our complexity. It doesn't even come close because it actually says that it's all random. But if it was random, would it be possible? The complexity of one human being, if I took all the DNA in you right now and I put it end to end, I can wrap it around the world 5 million times. That's compactified inside of you right now, making sure that everything is working properly. In a very, very complex way that cannot be reproduced easily. You're shedding 1 million approximately cells a second. Like you're moving and you're dividing cell to make up for the cells you're shedding. And when you're dividing cells, the cells know what to do. They divide in the correct order. So that your liver cells continue to make liver cells, and your heart cells continue to make heart cells, and your brain cells, everything continuously knows what to do. It knows how to differentiate. Because if it got confused about that, even for a few seconds, or a few minutes, it could be a problem. If your toe cells start to make nose cells, and your nose cells make toe cells, it would be very uncomfortable. In your shoes, I mean, you know. So this system is self-organizing, and there's nothing in biology, there is nothing in physics, there is nothing in chemistry, there is nothing in our science that explains how. And in general, scientists try to avoid this issue. Why? Because when you start talking like this, the tendency is that religious beliefs come in. You know, somebody says, oh, it's God. It's God that's doing it. He's organizing everything. But what is God? Well, when you think of the vacuum could do the job. Space could do the job because it knows what everything is doing. So let me give you a small mathematical example. Do you guys all have Rubik's Cube? Yeah, you have those, right? So, if you take a Rubik's Cube and you give it to a blind person, which is not a very nice thing to do, but you ask him to order it, and the person is able to move a move every second, you can calculate in probabilities how many moves the blind person has to do to go through the probability of ordering the Rubik's Cube. And if this blind person is like Superman, you know, and he can continue to move the cube, one move every second, you can calculate, and the answer would be past 14 or 13.7 billion years since the Big Bang. Actually, it exceeds the Big Bang by billions of years. Because the blind person doesn't know if they're getting closer or if they're going further from the solution. But if you tell that blind person one simple piece of feedback, yes or no, every time they move, yes, you're getting closer, no, you're getting farther, then the blind person will order the cube within 2.5 minutes. Billions of years are 2.5 minutes. And biology is much more complex than a Rubik's Cube. Much more complex. So, there must be an organizing agent. Is there a possibility that this organizing agent is actually a function of the space itself? Not some God sitting on a throne with a pair of binoculars. If you're a Christian, he would have a baseball bat, you know, in case you sin. Now, is that the case? Maybe the vacuum can do the job. Maybe the vacuum is not empty, but maybe the vacuum is full. This is something I concluded to very early. Is there any evidence that it's full, though? You know, I did a lot of this research living in a camper van because I was independently studying that allowed me to have my own thoughts. And so I had to self-finance. I was a professional skier for many, many years, professional climber. And I had to finance my own research. My budget was $2,500 a year. And most of it went to gas, so I didn't eat much. And, you know, eventually I got my first sponsors. And my first sponsors said, well, we'll help you. We'll pay rent and give you a little food. But you have to Go to physics conference. The one we picked. So I went for it. I wasn't so happy because I already had some difficulty with the physics community. But I went to this conference in Georgia Tech in Atlanta, and I brought this book. It's called Gravitation. It's kind of the Bible of relativistic equation. It's written by Wheeler, Thorne, and Mesner. It's the foundation of general relativity. And you can see it's quite a thick book, so you know everything you need to know about gravity when you try to pick it up. And in the middle of the book is this illustration at page 719. So I was in this conference, and I kept on asking fundamental questions, which was annoying a lot of the people in the conference. It was a small private conference with the director of the physics department there, other physicists, other mathematicians. And I was attempting to go back to the foundations of physics, and in advanced physics conferences, that's not really allowed. Everybody there has accepted the fundamental of physics, and you're not supposed to be rehashing it. You're supposed to be going into for 240 dimension of Calabi-Yau and superstrings and, very complex math, and you're not supposed to go back to the basics. So I kept on asking basic questions, and that was annoying everybody. I can have that tendency. But, at one point I said, you guys, I need to stop everybody because I have this question. And they said, okay, what's your question? And I said, well, I opened the book on this page, and I said, if I understand our universe as we describe it today with our equations, the example we give is a balloon. The universe is expanding, and we have little pennies glued to it. The pennies represent galaxies moving away from each other as the balloon expands. Well, I am a little confused because I said to them, I've been looking in all these physics books. I've been studying physics for a while now. I look everywhere. I can't find the equation. Can you guys show me where the equation is? Because, I might have missed it. I'm sure I missed it. Then I'll shut up if you can show me where the equation is. And they said, what equation? I said, I want to understand who's this guy. And, I got a different reaction than this. The room got very quiet. There was one of the students, PhD students, in the end of the table. He was drinking coffee and he went, and I could see the director of the physics department started to have a little sweat on his forehead because I think he thought I was going to say God, And he was like, oh no, don't say the word God in the physics department in front of my students. And I said, listen, let's draw the rest of the guy. If we draw the rest of the guy, notice that when the balloon expands, then the lungs must contract. For every action, there's an equal and opposite reaction. One of the first laws of physics you learn when you're a kid, right? Conservation law. Recently, I had an argument. Well, it's not really an argument because I didn't even bother answering it. Blog on the net. Saying, oh, he's confused about that. Let me give you another analogy. They said, the universe is like raisin bread. I was like, really? Raisin bread? And And the raisins are the galaxy. And as the bread expands, the galaxy move away from each other. I'm like, oh. And then he says, you see, no need for conservation law. I'm like, really? It is the nature of the bread to expand. Wow. This guy needs cooking lessons. I hope he's not doing the cooking at home. Because if you just put flour and raisin and water together, it's just going to sit there. You need an agent to make it grow. You need, yeast to make it grow. Yeast is a chemical reaction, is thermodynamic as well. It produces energy. You need energy for that thing to expand. Plus, you got to put it in, you got to put it in an oven, and never mind that you need a cook to make the bread. So, what am I talking about here? What I'm saying is that in the balloon is pressure pushing the balloon open. There's compression of air in order for the balloon to expand. There is an energy potential inside the balloon that's making the effect occur. And that part is not being understood. And the reason, because of this misunderstanding, most of our physics, most of our understanding is all about expansion, exploding stuff. Right? It's the male approach to the universe. Oh yeah, we get something that's highly explosive, we put it in a cylinder, there's a piston, we explode it, then we push a piston, and it turns the wheel, and it's like, yeah, let's blow some shit up, brah. We can blow stuff up. Expansion, radiation, it's all about that part of the equation. Nothing, very little is paying attention to the compressive part that must be there in order for the expansion to happen. Like our ideas of the most advanced technology for space travel, the most advanced thinkers on our planet work on these things, the engineers, is, for space travel, we make this big phallic symbol. Oh yeah, man. And then we put a lot of fuel in there, a lot of explosive thing, male approach to space travel. Oh man, we're going to blow some shit up. It's going to go up, bro. It will go up. A little too much testosterone. And then we put a little capsule on top of this cylinder, right? We find volunteers. We put them in the capsule. And then we light the bottom, right? Stand back. And then a few miles up, a little ejaculation. Poof. Only a few minutes later. The male approach to the universe. But in order for that fuel to be so reactive, in order for that fuel to be so powerful, it must have had compression of energy into it. It was in the earth, compressed. It was being energized. Where did the initial power come from? Our approach to the universe is that it all exploded into existence. But nowhere in our physics do we say where the energy came from to produce the explosion. Where did that come from? Instead of the radiative side, the general active side. I don't know if that translates very well. The centripetal side instead of the centrifugal side. The part that goes to the middle, the feminine aspect of creation, the part that creates, the part that nurtures, for the radiation to be able to occur. Where is that part? So, if this is true, then space cannot be empty space if space is the general active side, if space is the part that generates all of the explosion, if space is the source of matter, then space has to be full. Is there evidence that space is full instead of empty? Yes, there is. In that same book is this quote. When we look at the quantum level, present-day quantum field theory gets rid by renormalization process of an energy density in the vacuum that would formerly be infinite, if not removed by renormalization. Let me say that again. Of an energy density in the vacuum. You know, usually when you think of the vacuum, you think of it as empty. That would formerly be infinite if not removed by renormalization. Removed, the key word. Why is this? It's because when you look at the atom, it looks like a little oscillator. And then when you try to figure out in the oscillation what is, the smallest oscillation of the system, the smallest level of energy, you find that you can keep dividing and keep dividing and keep dividing, so you get infinite amount of energy. The vacuum structure inside the atom is oscillating with infinite amount of energy. So you would ask, why does it look like the vacuum? Why does it look like empty space if it's infinite amount of energy? Well, maybe it's because infinite amount of frequencies would all cancel out. And that would appear to you as nothingness. But where it doesn't fully cancel out, where there's a little bit of organization, then you would see it as the material world. Do you guys follow this? So, all of a sudden, the material world is a function of the oscillation of the space itself. It's just a beady little part of what's actually there. It's like thinking of the vacuum as full, and wherever it's leaking a little bit, we see it as matter, the material world.
Give your heart and your mind for that thing that you have to bring down, the way of living differently. But that depends on you and not somebody else. Because in this there is no teacher, no pupil, there is no leader, there is no guru, there is no master, no savior. You yourself are the teacher and the pupil, you are the master, you are the guru, you are the leader. You are everything. And to understand is to transform what is. To understand is to transform what is. To understand is to transform what is.
Pensacola, where's Pensacola?
I'll give you a hint.